The speaker is Alexandre Pham.
So hello everyone, as Sebastian said, I'm Alexandre Pham, so a PhD student at Lipsix. So I will be here to do a short elevator pitch. So I will talk briefly about my PhD topic. So I will talk a little bit about federated learning to introduce you to my, let's say, most different way of doing federated learning. And then I will talk about future works or what I'm doing currently. So what is federated learning? Federated learning is a way to deploy system based on machine learning to realize some task. So it was introduced by Google in 2016, and the first goal of federated learning was user privacy. So how does it work? So client can send machine learning models, and a central server can aggregate those models. So the usual way is a weighted average based on the size of the data set. And then the central server can distribute this model to clients. Those clients replace the old model with a new one. That is, so let's say the collaborative learning of the result of collaborative learning. Oops. One problem of federated learning that compared to, let's say, the usual way to do machine learning is that now we are open to attacks. The node that participate in federated learning can poison their model. So it was the topic of the first talk of this morning. And the second problem is more related to its architecture. So it's still centralized. So it doesn't scale well. So one solution is to decentralize the system. So we talked about gossip learning. So it is a way to do decentralized federated learning based on gossip techniques. I will introduce to you one easy way to do gossip learning. So periodically, for example, it's a laptop at the top, will send a model to a random neighbor. So here, what we can observe is that first, there is no central server and it is direct connection. Maybe it has an overlay network, but we don't care. It's a direct exchange. Then the node will do the node that receives a model will do a merge, and then it will do a local update based on the local dataset that is in the device. So around this work on gossip learning, so it just led to an international publication and a short French publication. So here, the goal was to propose a framework to analyze the spread of attacks in a system that is using gossip learning. To be more accurate, the attack that was used is a backdoor attack. So we introduce a small pattern on the inputs, and we see how it spread across the system. So the future works. What I'm interested in now is to do gossip learning on what we call here opportunistic networks. So, for example, vehicular networks when they are close to each other. And we are also interested in how we can use defense techniques against attacks into this kind of networks. And that's it. Thank you.